Alright guys, this video is the second stage of being able to look at how we can flowchart inputs, particularly digital inputs. So looking at how we can either toggle a button choice or we can just action something when a button is pressed. So we're going to look at those two inputs and then be able to do a couple of different things with the outputs from there, all around how we do our flowchart. So the first thing that we need to do with this is ensure that we are described. We don't need to worry about the COM port, we're just simulating this time, but we do want to tell what device we're using because the different that we choose here will impact what pins we have access to over here. So we're using a Nano. So what I'm going to do is I'm going to go through and I'm going to change my two buttons, my digital buttons, to be an input. So really important that we do that. Otherwise, when we go in, so if I just leave that one as an output for the moment, and I go into my flowchart and add a decision, I get input 2, but I don't get any of the others because that's the only input I've allocated from my pins. So I do need to go in and change this one to my input, and I'm going to use this one as a servo, and I'm going to use this one as a PWM just so that we can show that there's a few different ways that we can do this. So I've got my input. Now I always like to label these a little bit more. So I'm going to call this my input button press. And then this one is going to be my input, and it's going to be a toggle button. And we'll have a look at how the difference of those ones work. The PWM, I'm just going to leave it at that. So that could be a brushless motor, it could be a light, it could be a number of outputs, but we're just going to leave it generic at the moment. So what we're going to do is we're going to start, as we always do, with the start button. So this one's going to be start. Now, as we start to go into subroutines later, we could use some more meaningful names, but we're just going to leave that as start. So the first thing that I need to do is I'm going to do the basic one here. So when I get a button pressed, or if a button is pressed, then I want to do an action. So we're going to start with our decision. So that's our first step here. So as I drag that in, I want to be looking at that input button press. Now, because it knows it's a digital, so in on or an off, we're going to set it up here. So depending on how you've got that button set up, it may be a normally on, so it would be on, and then when you press it, it goes off, or a normally closed setup. So how you set that one up. So this one I'm going to say is a normally open. So when I press it, it's going to go on. So now I've got that set up, is input button pressed on. And if it is pressed, I want to be able to do something. So I'm going to go in and I'm going to make my output from there. So for this output, I'm just going to set my servo, and he's going to jump to 120. So when it's pressed, it's going to move to 120. If it's not pressed, it means that I want it to stay at 0. So then I'm going to bring my other output here, change that to be 0. So then they're my two options that we have coming out of that decision. So we go to the start node, we go to the input, and then check. So the easy way now, I would just drag that through. I might probably, a delay is often useful so that it's got some time to wait before we do anything else. So they'll both then go down to the delay, and we have our decision loop. The last thing we would need to do is then close that loop. So I'm going to change this so that we can use a subroutine and show you that as well. So this one's going to be my button pressed subroutine. So that's there. And then because we're doing a subroutine, I'm going to finish that with a stop. So now that is my subroutine. What I can do now is for my one that I want to run as the permanent one, this is going to be my start. Save that. And then I can bring in a subroutine straight under that. And I want that to be button pressed, loop it once, and then I go on to the next thing. At the moment, that loop is going to go straight from there back up to there. So that's a pretty short one. So if I go over to my emulator, I'm going to go simulate device so that I can play with it here. And I'm going to hit play to be able to run through this. Now, if you haven't seen before, we can actually slow that down to see what is happening. So you can see we're going through our start. It's checking that. If I turn my button on, the next time it goes through, we're going to see this jump the other way. And then no. Beautiful. And then I go back, and then we're going to turn our servo on. And then it jumps up. We turn it off, and it goes back down. So really simple little one. Now, that is our first way to be able to manage a button press. Now, if we wanted to do something a little bit trickier and actually have two actions from one button, so let's say we wanted to be able to toggle it between two states or step through multiple states, we could do that as well. So we're going to go back to our flowchart, and we're going to bring in another little routine. So this one I'm going to call button toggled. Okay, so there's my next one. Now, what we need to do with this one is we actually need to use this let. So this is a variable option. So I'm going to add a new variable. It's called A. And what I'm going to do with this is I'm going to use like just going from 1 to 0. Or if you had multiple options, you could go 1, 2, 3 and just cycle through that. And depending on what action you want to happen with each one, we can move this variable each time this button is pressed. So I'm just going to change that to be a number, and I'm going to start that on 0. Okay, so always starting button is 0. So I'm going to use this on the PWM going from 0 to 125. So let's start there. Now I've set that now. What I want to be able to check again is that toggle button being pressed. So I'm going to keep this as the same way. So it's a normally open. So when it's pressed, it closes and goes high. So that's now there. So I've got that. I'm checking that. If it is pressed, that means I need to check this guy. So now my decision comes down here, and I want to be able to check is my variable A, and I'm going to say equal to, and I'm going to go 0. So my two states, 0 means it's going to be down low at 0. If it's 1, it's going to be up at that 120 mark that I set. So I'm going to be going through and checking that. If it's not pressed, we're then going to skip this and then finish this little subroutine. But if it is A, so A is equal to 0, we need an output. So that output is going to set this one to 0. We save that. But we also need to then, let's get rid of that one. That shouldn't have come straight on. We also need to change our variable because that is our trigger. So we've just gone to 0. We need to change it to 1. So next time it's pressed, we're going to go into 1. So that's then finished. And if it's not, I need an output as well. So if it's not equal to 0 in this case, it's going to be equal to 1. So he'll go there. It's not 0, it needs to be 1, and then I need to change it to the next one. So then this A comes through, and I want to change that to being 0. So then he sits there, we finish that, and then we could have a delay again to be able to then check that. Or you might find it doesn't need it, but we're going to put it in there for the moment anyway. So then that goes through to there, and this one jumps straight through to the delay, and we check again. So I'm just going to move that over so he's nice and neat there. So now I've got my two subroutines to be able to check if the button is pressed or that toggle button is pressed. So let's have a look at how that works. So I'm going to move these guys over, and I need to add one more subroutine to that main run. So I'm going to bring him over there, and now I'm checking, is the button toggled? And then same deal, we're going to loop back around and check those. So let's go back over to simulate, and we're going to play that. And what did I forget down here? We need a stop node at the end of this so that it will actually finish that, or we loop back up to what we need. But good practice, we add that stop node so that it knows that that subroutine is finished and it can jump back into the main routine. So let's try that again. Okay, so he's running through. So if we have a look, he's gone through, check the next one. So I'm going to turn the toggle button on this time. That button we're happy with. Toggle button's been pressed. And now we should see next time it's pressed, it's going to jump across to be the next one. So he's pressed. And we've got our logic working there. Alright, so I'm not sure if you guys have noticed, but I've got a bit of an error with my logic in this flowchart here. So putting this up, so this is a really handy little view that we can see what our variables are doing, or we could go to the graph view. I find this one quite useful. So what we want to do is, if we play this, I've got it a little bit slower. What I want you to notice is this value that's going here, and we'll fix this up. So we've got A is now 0, it's now converted to 1, but then when it comes back through, what are we doing every time in our loop but setting it to 0, so we never actually get to here, even though that toggle button should be flipping across. So we need to fix this up. Any of our variables that we need to initialize need to happen outside our loop. So this guy here we need to take out, and he needs to move over either in his own subroutine that happens outside this loop, but because we've only got the one to initialize, I'm just going to bring him in over here. So we're going to start our loop at 0. So then the first time it's going to set through at 0, and then next time it's going to jump out. So let's try that again. So what we should see now, my toggle button's still on. We're going through, and now it goes through that the first time. Happy days. We see our variable is 1 right now. It goes through, and now we jump over and our PWM changes. So literally one box in the wrong spot will mess your whole logic up. So making sure you take the time and look back over what you're doing and how it's working is really important. That ability to slow it down, to be able to look at what we're trying to achieve and break it down, is really helpful. So now I've got that, I'd be able to connect it through to my device and test it through. Remember, if I need to export this, I can save the state that it is now, or I can take a screenshot to be able to share my logic with somebody else. Good luck with your flowchart using your digital inputs.